Right now, somewhere in your house, a moth is seeing better than you ever will. So is your cat. So is the owl outside your window. But the real answer to why you can't join them is far stranger than your eyes are just weaker. Your eyes are not broken. They are the result of a trade you never agreed to, a trade made 80 million years ago by ancestors so small they could fit in your palm, and you have been living with the consequences of that deal every single night since. Here is what it would actually feel like if you had night vision. Not the green, grainy kind from a war movie, real, biological night vision, the kind an owl has. Walk outside tonight and the world would not go dark. It would shift. Shapes would hold their edges. Colors would fade, but detail would stay sharp. You could read a street sign from 50 feet away under nothing but starlight. Why don't you? The answer starts with a cell so small you could fit 1,000 of them on the head of a pin. It's called a photoreceptor. Your retina, the light-sensing tissue at the back of your eye, is packed with two types, rods and cones. Cones handle color and fine detail, but only in bright light. Rods handle motion and shape in near total darkness. Here's the part that changes everything. You have about 120 million rods. An owl has almost the same number packed into an eye 10 times more efficient at gathering light. So why does the owl win? It comes down to a single molecule called rhodopsin. Nobel laureate George Wald spent decades studying this exact protein, and what he found reshaped how scientists understood vision itself. Rhodopsin is what makes your rods sensitive to light in the first place. It bleaches when light hits it, then has to regenerate before it can file again. In animals built for darkness, that regeneration is fast, almost instant. In you, it's slow, painfully slow. That's why you stumble into furniture the first 30 seconds after turning off a light. Your rhodopsin hasn't caught up yet. But slow regeneration isn't the real story. The real story is a decision your ancestors made without knowing they were making it. Around 80 to 60 million years ago, the earliest primates were small, tree-dwelling, and almost entirely nocturnal. Their world was built for darkness. Then something changed. Flowering plants exploded across the planet. Fruit became abundant, and fruit, unlike shadows and shapes, rewards color vision. A primate that could tell a ripe red fruit from a green one at a glance from a branch away had an advantage that no amount of night sensitivity could match. So evolution made a trade. Slowly, generation by generation, primates began shifting resources away from rod density and toward cone density. Zoologist Gordon Walls, whose comparative studies of vertebrate eyes remain foundational to the field, described this shift as one of the most dramatic sensory reorganizations in mammalian history. Your ancestors didn't lose night vision by accident. They spent it on color, on fruit, on being able to see a threat's face instead of just its shape in the dark. Does that sound like a bad trade? It wasn't. Trichromatic vision, the ability to see red, green, and blue as distinct colors, is rare in the mammal kingdom. Most mammals are dichromats, seeing the world in a narrower band of blues and yellows. Your dog cannot see the redness of a stop sign the way you can, but you paid for that vividness with your night eyes. Research led by neuroscientist Gerald Jacobs, who spent much of his career mapping the evolution of primate color vision, showed that this three-color system likely emerged more than once across primate lineages, each time trading away low light sensitivity for the ability to distinguish subtle shades. Every sunset you've ever found beautiful exists because your ancestors gave something up for it. Here's where it gets stranger. You didn't just lose rod efficiency, you changed your entire relationship with the day. Nocturnal animals typically have large corneas and wide pupils to gather every scrap of available light. Somewhere along the way, your ancestors' eyes shrank those structures and shifted the whole visual system toward daylight operation. Biologist Nathan Lentz, who has written extensively on the imperfect engineering of the human body, points out that the human eye is full of these leftover compromises, structures shaped by ancient priorities, still running the show millions of years later. Your night blindness isn't a flaw, it's a fossil, a living record of a decision made before your species even existed. Think about what that means. Every time you squint walking from a bright room into a dark one, you are feeling the echo of a fruit tree in the Cretaceous period. Every time headlights blind you on a highway at night, that's 80 million years of trade-offs arriving all at once in a single uncomfortable second. So what would it cost you to actually have owl-level night vision today? More than you'd think. Owls sacrifice almost all color perception for that sensitivity. Their color vision is dim and washed out compared to yours. Cats similarly live in a muted, less saturated world in exchange for their nighttime clarity. If you had true night vision, the sunset you love, the red of a strawberry, the exact shade of your favorite shirt, all of it would flatten. You would gain darkness, you would lose color. Is that a trade you'd actually want? There's a term researchers use for this whole phenomenon, the nocturnal bottleneck hypothesis. It proposes that early mammals, living in the shadow of dinosaurs for over 100 million years, were forced into nocturnal life simply to survive. Only after the dinosaurs disappeared did many lineages, including your primate ancestors, drift back toward daylight, carrying nocturnal leftovers with them the whole way. Your eyes are, quite literally, built on the bones of a 100-million-year hiding strategy. You are descended from creatures who survived an extinction event by staying small, staying quiet, and staying up all night. And then, once the coast was finally clear, they decided color mattered more than darkness. That decision is why you flinch at shadows in an unfamiliar room, why your ears do more work than your eyes when the lights go out, why humans, across every culture on Earth, invented fire, torches, candles, and eventually electric light, over and over, independently, as if compensating for something missing. Because you were. You are not adapted to the dark. You are adapted to color, to fruit, to detail, to faces. The dark is simply where those adaptations stop working, and every flashlight you've ever reached for in a blackout is a small modern echo of an ancient trade your ancestors made back when the biggest danger wasn't what was hiding in the shadows, but what color the fruit was on the highest branch. So the next time the power goes out and you feel your way along a wall in total darkness, remember what you're actually feeling. Not a weakness, not a defect, a receipt. Proof of a deal struck 80 million years ago between a small furry creature and a world full of color it decided was worth losing the night for. Somewhere out there, a moth is still seeing better than you ever will tonight, but you can see the exact shade of red on its wings the moment the sun comes up. Your ancestors already decided that was the better deal.